Assalamu alaikum. Today our topic is buffers, in which we will explain about what is buffer, types of buffer, importance of the pH stability in the buffers, and mechanism of the buffer, how buffers work. Okay, and buffer capacity, like how much it resists changes or how much it can absorb the changes in it. And then we will explain about the Henderson Hasselbalch equation, and at the last I will tell you about the common buffer systems which are used in daily life. What is buffer? The buffer are a special type of a chemical solution that resists sudden changes or large changes in its pH. Whenever a small amount of strong acid or strong bases are in it, it will resist these changes. Okay, and buffers are act like a shock absorber. Whenever a changes occur in it, it will absorb these shocks and these changes and maintain its normal pH at constant. Okay, buffer is not a single chemical, but it is a mixture of two components that work together. Type of buffers, there are two types of buffer: acidic buffer and basic buffer. So first of all, what is acidic buffer? Acidic buffer are made up of weak acid and its salt with a strong conjugate base. Weak acid does not ionize completely, and the salt provide the conjugate base. Why we used weak acid? Because it will ionize slowly. So whenever a strong base is added in it, it will absorb all the changes in it. Okay, and its example is acetic acid plus sodium acetate. Combined they will form the acidic buffer. This type of buffers maintains pH below 7. It will mostly neutralizes the bases. Whenever a strong base is in added, it will neutralize it. Acidic buffers also slightly neutralizes acid as well. Common pH range of this buffer is 3 to 6. Applications of it in food preservation, skin creams and beverages. Second type of buffer is basic buffer, which are made up of weak base and its conjugate acid, and the salt in which its conjugate acid is present. Weak base also partially ionizes, and salt provides the conjugate acid. Its example are sodium hydroxide plus ammonium chloride. Combined they will form the basic buffers. Basic buffers maintain its pH above 7. Common pH ranges are 8 to 11. Its applications are industrial cleaning, electroplating and mining. Why we use weak acid and weak base in buffers? Weak acid and bases can accept or donate H plus ions, protons versus ions slowly, which allows gradual neutralization instead of sudden pH change. Importance of pH stability. We know that many chemical reactions are pH dependent, like enzymes which are work on a specific pH range, and biological cells stop functioning outside a narrow pH range. Okay, industrial processes may fail or produce defects in pH fluctuations. Therefore, buffers are essential for precision and safety. The fourth point is mechanism of buffer, like how buffers work. Okay, so we took the example of acetic acid buffer system, which is the example of acidic buffers. Whenever the case one is whenever a strong acid is added, it like a proton is added in the solution, it will automatically lowers the pH of the solution. At the same time, acetate ion in the salt of sodium acetate, in the form of sodium acetate present, will react with these extra protons and form the acetic acid, and the pH will drop very small, because we know that acetic acid is a weak acid and a single proton is a very strong acid. So whenever a proton react with the acetate ion, it will form the acetic acid and the pH drop will be very small. The second case of buffer mechanism is whenever a strong base is added, like hydroxide are added in the solution. The pH will increase very high because hydroxide is very strong base. At the same time, acetic acid neutralizes these hydroxyl ions and form the acetate ion and water. And water is a neutral which have a neutral pH, and acetate ion will lowers the pH but not very much. So there will be small rise in the pH. We expect that whenever hydroxyl a strong base is added, the pH should be rises very high, but it does not occur because buffers neutralizes these hydroxyl ions. The fifth point is buffer capacity. What is buffer capacity? Like how much acid or base a buffer can neutralize before pH changes significantly. So it all depends on the different factors. Okay. Whenever there is a buffer present in the high concentration, then this will be the strong buffers. Okay, second is ratio of the acid to salt. Best buffers are those which in which the acid to salt ratio is 1:1. Temperature, the higher the temperature can change the equilibrium, because we know that the temperature causes ionization very easily. Dilution, excess dilution reduces effectiveness. Whenever the water is in large amount and the main components of the buffers are in small amount, then automatically the action of the buffer will be reduced. Henderson-Hasselbalch equation, which give us the formula that pH is equal to pKa plus log salt by acid, meaning it shows that pH depends on the ratio, not just quantity. Like pKa shows the acid strength constant, how much the acid is strong or weak. Okay, if but it this formula also shows that if salt is equal to the acid, then pH will equals to pKa and maximum buffer efficiency will be noticed. Here are some common buffer system like phosphate buffer system, in which sodium dihydrogen phosphate and its salt is disodium hydrogen phosphate. Its pH range 6 to 8. It is main uses are in blood and pharma. Like acetate buffers, which is used in food and cosmetics. Its pH is in 3 to 6. Carbonate buffers, ammonia buffers, citrate buffers, which are used in mining and water, industrial labs, and the citrate in medicines and beverages. Thank you so much for listening my lecture. If you think it is helpful, then like, subscribe and share it with other students.